Today we're going to have some fun overclocking the painfully slow but gorgeous IBM PS1 SX25. So far we have hacked the supposedly unupgradable IBM from 10.6 FPS to respectable 38.6. In this video we're going to see if we can go even faster. We're going to try with better cooling and more stable power. We are also going to take a look at a real vintage Interposer from 1997 to see how they solved the problem back in the day. As it turned out, we also got a surprising result, overclocking a relatively cheap and common 486. This video is sponsored by PCB, who supplied the PCBs we're going to use today. Thank you PCB for supporting this channel. Okay, I pulled the motherboard out and did a quick test with an ODPR100. It's still working, but I'm having some trouble with the diskette drive. And I turn the machine on. The motor spins up and the LED turns on and then off again. But then nothing. It's not even trying to seek. Well, I did an inspection and I can't see anything obviously wrong. So let's disconnect the heads, the stepper and the zero track sensor. There is one electrolytic cap here, but I can't see any corrosion. So let's lift this PCB off and see what's underneath. This is, by the way, a YE data drive. Let's flip this over. No electrolytic SMD caps here. Just one regular cap here. I guess I'll inspect the PCB. No, I can't see anything suspicious looking here. This drive is clean and everything looks okay. But since SMD caps this vintage are known to go bad, I'm just gonna go ahead and replace this guy. Even if this is not the fault, this cap needs to be replaced anyways. Before I install a new cap, I'll clean up those pads. Need some Flux and wick. We better clean that Flux up. And we can install a fresh cap. But first some fresh solder on the pads. I think I can just about reach this pad with this large tip. And then I'll add some more solder to this side too. We might as well replace C8 too. I found one in my stash, so we might as well replace it. It's a 10 microfarad 16 volt cap too. So I'm a bit surprised that they didn't use an SMD cap here, like on the other PCB. Yeah, I found an identical cap in my stash. Same brand and all. So we might as well use it. Through-hole caps aren't going to last forever either, of course. But I rarely find bad through-hole caps from this era. So they just seem to last longer than SMD caps. Let's snip those legs and clean up the PCB. Okay, let's try again. It spins up, LED turned on and off again, but it still doesn't seek. Let's see if we can turn that stepper motor manually. Yeah, it's definitely moving. So the stepper is not stuck. And we'll see if the heads move to track 0 when we turn the machine on. Well, they actually made a very small movement when I turn the power on. The motor spins up, but the heads are not moving. Well, that kind of sucks. When the power is turned on, the heads are supposed to go all the way back to track 0 before they start seeking on the diskettes. Well, check this out. I found an identical drive in my stash. Slightly more yellow, but otherwise identical. So let's see how it behaves. Turn the power on, and it immediately spun up. Unlike the other drive, and the heads moved slightly, and now they moved again. So it's definitely behaving differently. The motor spun up, and it seeks. And the machine boots. Well, I don't want to spend this video repairing a diskette drive, especially since we repaired the diskette drive very recently in another video. So I just swapped the front panels, and we now have a working drive that gets to stay in this machine. And if we ever need one of these again, we'll repair the other one. Okay, long story short, these machines came with an SX25 soldered directly to the board, and with no other options. So we have disabled it with a bodge wire underneath. That allows us to install whatever CPU we want in the Mathco socket instead. Unfortunately, this board can't take more than 8K of level 1 cache, so it disabled all cache, but then Tom helped us and hacked the BIOS, so we can now use however much level 1 cache we want. We have also installed more VRAM directly to the motherboard with an extra chip. And finally we managed to change the clock speed of the board by moving a few resistors that are connected to this chip here. At the moment this board is running at 33 MHz. That allowed us to run the 5x86 at 133 MHz. So that is the fastest speed this board has done yet. However, we got a slightly better score at 120, but when we went for 160, Doom crashed. So that's what I'm hoping we will reach today. So the speed of this clock chip here is controlled by these 3 resistor pads here, and by installing resistors on these 2 pads here, we got 33 MHz. And the only thing we need to do to increase the speed to 40 MHz is to remove this resistor here, like so. I'm gonna leave it connected to just one of the pads here, in case we need it later. It will be easier to find, because these things are absolutely tiny. While the ODPR100 is designed to run at 100 MHz, but I accidentally ran one of these at 120 MHz. And it actually ran until I pushed it and ran Doom. Then it crashed. So before we continue, let's be a bit silly and see how it will behave with some extra cooling. This is far from ideal, but it's a fun experiment. And then we'll just put a huge cooler on top. Man, this is silly, but it's fun. Let's turn the machine on and see if it will post. And it's counting up the RAM at 120 MHz. Let's see what temperatures we're running at. It's at about 34 degrees Celsius. That's actually cooler than some of the chips on the motherboard. So by the looks of it, some of the heat is going up on that silly cooler. The cooler is actually moving. It's trying to slide off that CPU. So I'm gonna have to keep an eye on it. Let's see if we got any benchmarks here. Okay, let's see if it will run Doom. Well, it starts. And it's running pretty fast. Let's check the temperatures. 35 degrees Celsius. That's not too bad. I can see some random pixels on the screen. So it's not running perfectly. And then it crashed. Okay, so it's not just the cooling, because that ODPR is still below 40 degrees Celsius. So it's not running too hot. It just can't handle the speed. Now, this was actually kind of fun. So the overclock ability from one CPU to another varies quite a bit. So let's try another one. This is an ODP100. It's identical to the ODPR100, but it has an extra pin. Let's see if this guy will cope with Doom at 120 MHz. So let's add that big silly cooler and see if it will do 120 MHz. Well, it posts and it boots. Well, it's stable enough to run Windows, but how about Doom? Okay, fingers crossed. And it runs really fast. I mean, this is definitely playable. Well, there's actually a lot less messed up pixels with this CPU. I think maybe this is... Oh no! Oh, it crashed. Map plane something or other at 255. Press any key to continue. Well, it didn't actually crash the entire PC. Just the benchmarks. So this guy here almost made it. How about something easier? like Superscape 3D Bench. Well, it's obviously really quick. I wouldn't normally use this benchmark on a fast 486. 66.3, and it didn't crash. So this CPU can almost run at 120 MHz. That's pretty cool. So how about the temperatures? 47 degrees Celsius. That's not too bad. Those are pretty decent temperatures. Well, I know this is completely off topic, but I'm having too much fun to stop here. So I found another one of these. And this is a regular ODPR. Now let's see how this guy performs. Fingers crossed. It posts. And it boots. So how about some Doom? Well, it starts. And again, I can see some random pixels here that shouldn't be in the game. And it's definitely running at a playable speed. Okay, now let's see if it's more stable than the other two. Fingers crossed. Come on, ODPR, you can do it. Oh, so close. Come on. Yes, it worked! And it finished at 1916 real ticks. So there you have it, with some additional cooling. You can run some, but not all, ODPR 100s. You would obviously have to find something a bit more elegant than this big pile of cooler. But hey, it's possible, and very doable. Holy smokes, I just did the math. This is a record for this board. With 1916 real ticks, we actually just reached 38.98 FPS. That is actually faster than 120 MHz with the 5x86. Well, this was completely off topic, but apparently the ODPR 100 is slightly faster than the 5x86 at the same speed. And since these guys here are running at 5 volts, they don't need an interposer. So this is actually much cheaper and easier choice. But again, you may have to try a few before you can find one that is stable enough at the speed. Well, this was completely off topic, but this may actually be the title of this video. We'll see how it goes. But this was definitely a win, and rather interesting experiment. With a big silly cooler, the temperature is still stable at around 40 degrees Celsius. Well, interesting finding or not, we're going for 160 MHz today. So this is a 5 volt only board. But thanks to Scrap Computing's awesome interposer projects, we can now add 3.45 volts to any board. So let's add a 5x86. In our previous attempts we have successfully run the CPU here at 120 and 133 MHz. But when we went for 160 it crashed. By the way, if you want to build one of these up, I will put some information down below to where you can order these PCBs from the sponsor of this video, PCB. I have also made a video showing how you can build one of these. You will find all the information down below. Thank you PCB for supporting this channel. The board is obviously running at 40 MHz now, and I think the interposer is set to clock multiplier of 3. So in this test here we're gonna go for 120 and just make sure that everything works. And for this test I'm going to use what I think is a Pentium 1 heatsink. Okay, and according to SpeedSys we're running an AM486DX4 at 120 MHz. And we're getting a score slightly lower than AM5X86 running at 133 MHz, which is actually incorrect. We actually got a few FPS more running this CPU at 3 times 40 than 4 times 33. Okay, so Let's change this jumper here. This will set the 5x86 in 4x mode, running at 160 MHz. Okay, let's see if it will crash again, like it did in our previous attempt. Oh wow, it doesn't even post. None of my 5x86s are tested at 160 in any machine. Okay, so let's add the beefy cooler. It's kind of silly, but it's really useful for tests like this. Well, since our previous attempt, I have actually picked up 2 more of these. So let's just try another one. Okay, fingers crossed. Most of these 5x86s are overclockable, so I don't think the issue is the CPU. But let's test these guys anyways. It posts, and it boots, and then it hanged with a very annoying beep. Okay, let's change tactics. Instead of guessing, I pulled out the TechMedia board, because this board can take 5x86 without the interposer, in 4x mode and all, and I tried all my 5x86s, and as you can see, more than half of them would happily run at 160 MHz, and that's with a heatsink for what I think is a Pentium 1. So now we don't need to guess anymore. We'll continue with this CPU here that we know will run at 160. I haven't done a follow-up video of this board yet, because I still don't have the matching case. But I'll keep looking, and eventually I will find one, and I'll make a video, because this is a pretty interesting board, and it's pretty damn fast. I haven't pushed it to its limits yet, but the tests I have done are very promising, so this board will be back in a future video. So that test tells us that more than half of the CPUs we have tried should run at 160, and this is not a cooling issue. And that leaves us with power. Unfortunately, these buck converters are very unstable at higher voltages, especially without load. As you can see, it jumps around between 3.7 and 4.6. We could try to increase the voltage, but that is pretty risky at 4.6 volts already. And this buck converter is only adjustable with the CPU removed from the board. So we can't install the CPU and put it on the load and then adjust it. That would be ideal, of course. With the CPU installed, the buck converter stabilizes at roughly 3.2 volts, which is too low. So this could definitely be a power issue. So we could increase the voltage, but then we will zap the 5x86 with 5 volts. I can't really tell if the CPU will load immediately and drop down the voltage, or if it will get zapped with 5 volts or whatever we set the voltage to before it drops down to 3.45. So that's a bit risky. That brings us to this loaner here. This awesome thing here is an original interposer from the 90s. This is a Trinity Power Stacker 5x86, 133 MHz. This awesome interposer here unfortunately has a GAL chip, so it can't be cloned easily, but I'm sure someone can figure this out. Let's start with this side here. So first we have a switch block, and then we have a 74 HC74, and this guy here is a TC7W04F, and that's a high-speed CMOS buffer. And the rest of the components on this side are just caps and a couple of resistors. And on this side of the interposer, as I mentioned, we have a GAL chip. There's a crystal, a whole bunch of caps. And here's the interesting part, at least for today's video, because this voltage regulator here is a Linfinity LX8384. I managed to find the datasheet, and this guy is rated for 5 amps. Now, if we go back to the modern interposer, we've got a much smaller voltage regulator here. This guy here is an MP1584. It's rated for 3 amps, which, at least in theory, should be enough to run an overclocked 5x86. But I did some reading online, and quite often the chips on these cheap modules from AliExpress, they are fake. So one way to go about this would be to order a proper chip from a well-known supplier and replace it. The Linfinity chip, by the way, is long since obsolete, so even if we could find one, it doesn't make any sense to design it on a modern board. Another option would be to use a different chip. Now that would make a lot more sense, but unfortunately, same problem here. One of these modules cost a lot less than just a chip from a well-known supplier. So it's pretty much a guarantee that these guys here are fake too, and won't cope for the rated amps. By the way, these modules work well enough for most applications, but the switching frequency will be completely off, and I seriously doubt that they are good for 3 amps. But if designed with a genuine chip, this could be a really cool option for the Interposer, or maybe even pick something beefier, like on the original Interposer from the 90s. One possible problem is that these guys here are using some really beefy caps that wouldn't fit inside the Interposer. But then again, the original Interposer is using 22 micro 10 volt caps, so it's probably not an absolute must. I don't really see the need to use a 50 volt cap like this guy here, because this module is designed to work at 35 volts. But the Interposer only requires 3.45 volts, well, perhaps 4 volts for overclocking. Unfortunately, the Trinity Works module is only good for up to 133 MHz, so we can't use it to go to 160. That would of course have been interesting and fun to see if our board would cope, but the most important thing is how we can get more power to these boards, to find out whether this is a power issue or not. Let's do some tests, see if we can shed some light on this. Let's start with LM2596 and see if it's up to specs. I have set the module to 4 volts, because that's most likely what we need to overclock the 5x86. I have connected the scope in case it does something interesting. Now let's crank the load up and see how it behaves. Let's start with 1 amp. Well, it dropped to 3.9 according to my dummy load. That's what the scope says too, so that is probably correct. So that's not great. We're gonna need about 3 amps. So let's crank it up to 2 amps. And it dropped to 3.4. Well, it's not doing anything crazy, but the voltage dropped to 3.4 volts. So how about 3 amps? And it dropped all the way to 2.7 volts. So 5 volts isn't enough to keep the LM2596 stable at 4 volts on the load. But we actually have access to 12 volts in the PC too. So let's give that a try. So we still have perfect 4 volts without load. Now let's crank this up and see how it behaves. Let's go to 1 amp. Still 4.0. That is excellent. But it doesn't look as good on the scope actually. It got slightly wavy, but nothing crazy. So let's continue to 2 amps. Yeah, that's pretty good. We are still at perfect 4.0 volts. Oh, it started to make a noise at 2.5 amps. We better check those temperatures. Let's set 40 without load. So that's perfectly fine. Now let's crank it up again to 1 amp. Still at around 40. That's okay. So let's go to 2 amps. 55. It keeps rising. So how about 3 amps? 72. 77. This isn't looking too good. 85. 90 degrees and it's still climbing. 95. 99. Oh, we better turn that thing down. That chip is burning hot. So, the fake LM2596 is completely useless for the project. At least without a huge heatsink. So I'd say that was a complete fail. And again, this is most likely a fake chip. But at least it could hold 4 volts stable with 12 volts in. Okay, so how about the MP1584 module? Let's turn the power on. And it's set to perfect 4 volts. But look at that thing here, how it jumps around. Just like I showed you earlier in the video with the multimeter. Yeah, look at that mess. That is not what I would call nice and clean 4 volts DC. So this fake chip here sucks even without any load. But let's add some load and see how it behaves. Wow, what a mess. Okay, 1 amp. And it dropped to 3.6 volts. And it makes a really annoying noise. Oh, the PC just did a reboot. What the heck? And I only had 1 amp of load. Okay, so PC is up and running again. Let's try that again. Yeah, it starts to make a really annoying noise at just 1 amp. And the pitch goes higher and higher. Look at that mess. And now it jumps around between 1.5 and 3 volts. So how about the temperature? Oh, it's over 100 C. That thing is burning hot. So the fake MP1584 is completely useless, even with just 1 amp of load. And somehow it managed to reboot my PC. Let's just quickly go up to 2 amps and back again. See what happens. Yep, the PC just did a reboot. So not only is it sending crap out on the outputs, it seems to be sending some crap on the input too. I think this chip is obsolete, but I'll see if Mouser still has any. In that case I'll order a chip, and we can try out a real chip instead of this fake crap. There is of course a possibility that this module is bad, and if it wasn't already, we might actually have killed it with this test. But it's actually still outputting 4.0 volts. Well, the whole point of this video was to see if we can get the slow IBM PS1 to 160 MHz. But instead we found out that the ODPR100 is slightly faster than the 5x86 at 120 MHz. Now this could of course be because of more stable power. The ODPR100 has a linear technology LT912CM. I couldn't find a datasheet unfortunately, so we don't know what it's rated for. I will of course keep trying and make another video. I'll put a link on the screen here when it's done. Meanwhile, check out this video. I will end by saying thank you to my patrons. I appreciate your support. If you want to support me too, consider becoming a patron. Patrons get ad-free early access. If you like this video, let me know with a thumbs up in the comments. If you're a regular viewer, consider subscribing to this channel. Thank you for watching. I'll see you next week.